So this is project 9. We're going to download the IMU data from the Arduino to the Raspberry Pi to the host, but this time we're going to use Bluetooth. So it's very similar to project 8, so most of the requirements are the same. The IMU sensor is connected, we're getting our yaw, pitch, and roll data, we're using the exact same script as we did last time, so we're still using FreeRTOS. We're sending our IMU data over serial to the Raspberry Pi. And then to send the data to the host, this time we're using Bluetooth, and that's the only difference. So most of this I preserved just, but I'm not going to spend too much time going over it. Design is exactly the same as Project 8. Wiring is all the same as Project 8 with the BNO 055. The Arduino is attached to the quadcopter in the exact same way. The only difference is we are set up for Bluetooth rather than Wi-Fi. So set up the Raspberry Pi just like in Module 6. Set up the IMU transmission between the Arduino and the Pi just like in Module 8. And now for the new stuff, to configure the Raspberry Pi for Bluetooth, we wanted to create a file, btserial.sh, which is in the instructions for the class, but that wasn't working for me, so I looked at Alex's implementation and he did it slightly differently, and so this is what mine looks like below. The differences are mainly in this exec start command, and then there's a line that's left out here. Then we're going to make that file executable, and we're going to run it when we start up by adding it to etc rc.local. So this will run on startup every time, and so then you just need to reboot the Raspberry Pi so that this runs. And what it's doing is it's setting up the Bluetooth service so that it's discoverable in the background. So then we need to configure our laptop so that it can connect to Bluetooth over a COM port. So in settings, devices and printers, open up the Bluetooth settings for your laptop, and then you can add a COM port. So you're going to select outgoing, and if your setup on the Raspberry Pi worked correctly, you'll have the option to select Raspberry Pi here. And then now it'll associate the Raspberry Pi with a COM port. So super easy and straightforward. And then you go to PuTTY, and now that we know that it's COM7, and we know that the baud rate is 115,200, we're going to connect through that, and this will open up a terminal session. All right, so type our username and password for the Pi. It's a little bit slower over Bluetooth than it was over Wi-Fi, for me at least. But now here we are, we're in the Pi. So I have a script that makes it really easy to run the IMU data. It's just display IMU. Basically, it's just making a serial connection and then reading in the data and printing the data out. So very straightforward. We're going to run this and we will see if we can see our IMU data. Calibrating for a second, and now you can see the yaw, pitch, and roll changing. I'll move the sensor around so that we can see some variation. So as the yaw goes side to side, the pitch when I go up and down, and the roll when I tilt. So that seems to be working as planned, and now we'll show it in flight.